Hello friends, in this video we discuss the subject called heat transfer, which is nothing but it is the transfer of heat from one phase to another phase. It is the most important subject especially for petroleum engineers. Okay, now in this video let us know the equation for steady state conduction, which is a subtopic in heat transfer. Okay, without any pause, let's move on to the topic. Steady state conduction. Okay, in this steady state conduction, we must have two tanks. The tank is a flat walled insulated tank, and the two tanks why means one is heat flow into the tank and the another tank is the heat flow from the tank. Now a flat walled insulated tank which contains a refrigerant. Here it is the flat walled insulated tank. It contains the refrigerant. See here it is a refrigerant and it also contains a tank wall. Here it is a tank wall. Okay. Now a refrigerant, it is at minus 10 degrees centigrade. See here it is the minus 10, 0 and it is minus 10 degrees centigrade and leaving the heat out here the air. Here it is in 28 degrees centigrade. So the air outside the tank is at 28 degrees centigrade and the refrigerant is at minus 10 degrees centigrade. Let us consider this type of tank for steady state conduction. Now here when the heat flow into the tank, that means the heat is coming into the tank. The heat is coming into the tank, that means flowing into the tank. Here from 28 degrees centigrade to flowing, it is in linear. It passes linearly to the refrigerant at minus 10 degrees centigrade. Yeah. Okay, let's move on to the another tank, which is the heat flow from the tank. See here also it is the tank. It is a flat walled insulated tank which contains the tank wall, but here it is a boiling water because we are considering the temperature here is 100 degrees centigrade, so it is a boiling water. So this figure shows a similar tank containing a boiling water at 100 degrees centigrade. When we observe that heat is flowing from the tank, so we can say that here the heat is losing. See here this line indicates, this means the heat is losing the temperature from 100 to 20 degrees centigrade. Here see it is 0, 20, 60, 80, 100 degrees. So it is losing the heat from 100 degrees centigrade to 20 degrees centigrade. Here also it follows a linearity, but comparing to the tank which is a heat flow into the tank, here it is in reverse direction because it is losing the heat from 100 to 20 degrees centigrade. So it is in reverse direction. Okay. Now for steady state conduction we have to assume some conditions. So the assumptions for steady state conduction are thermal conductivity is independent of temperature. Thermal conductivity should be independent of the temperature, and as it is in steady state there should be neither accumulation nor depletion because it is in steady state. And Q, which is the heat flow, it is constant along the path of the heat flow. Okay, I'll show you. Here it is the path of the heat flow which is coming from here to here, so it is independent of the path of the heat flow. Sorry, it is constant. Now let us derive the equation for the steady state conduction. Okay, so for derivation we have to thorough about the Fourier's law. What is Fourier's law? Fourier's law is nothing but the rate of heat flow is directly proportional to the area. Here it is the heat flow, the rate of heat flow is directly proportional to the area and directly proportional to the temperature and inversely proportional to the x, which is known as the thickness or distance or length. Anything. Here in steady state conduction we can assume that the x is the distance. Okay, now So by removing the proportionality, we can get the proportionality constant, which is nothing but K. Here K, which is the proportionality constant, it is known as the thermal conductivity, which is represented by the K. So from Fourier's law, we can write this equation as Q by A into dx is equals to minus K into dt. From this equation, we derive the equation for steady state conduction. Okay, let us see how to derive that. Okay, we know that the equation from this equation 1, integrating the equation 1, which is Q by A into integral x1 to x2 dx equals to minus K into integral t1 to t2 dt, where x1 and x2 and t1 or t2 or t2 are the temperatures and x1 or x2 are the distances. Let us see where x1, x2, t1, t2 are present here. Here it is the x, is the x1 and this is x2, and the temperature here is t1 and the temperature here is t2. So yeah, here after applying the integration, the equation becomes Q by A into x2 minus x1 and minus K into t2 minus t1. Now this can be written as Q by A equals to minus K into t2 minus t1 by x2 minus x1. Negative sign can be removed by changing this t1 minus t2 into K, because t1 minus t2 is t2 minus t1 equals to minus into t1 minus t2, and minus into minus becomes plus. Now let us consider this x2 minus x1, which is nothing but thickness or length or distance. Let us consider this as B, which is thickness of layer of insulation. Now, and T1 minus T2 is nothing but change of the temperature, which is denoted as delta T. So T1 minus T2 can be written as the delta T, and x2 minus x1 is written as the B. Now this equation. So from this equation, to derive the equation, we have to know what is the resistance. Resistance in heat transfer, it is nothing but the ratio of thickness to the thermal conductivity. So it is the ratio of thickness to thermal conductivity, which is nothing but B by K. So here in this equation, we can written this equation as delta T by B by K. See here. So delta T by B by K. Here B by K is written as the R, which is nothing but the thermal resistance. Okay. So this is the equation where Q is the heat flow, A is the cross sectional area, delta T is the temperature difference, and R is the resistance. This is the last equation for steady state conduction. Now we know that the ratio of the thickness to the thermal conductivity is nothing but resistance. The reciprocal of the resistance is nothing but the heat transfer coefficient, which is denoted as H. So H can be written as K by B. R and H, resistance and heat transfer coefficient, they depend on dimensions of the solid as well as the thermal conductivity, which is K. And we know that the thermal conductivity, it is nothing but the property of the material. So this is the equation. So okay guys, this is the equation for steady state conduction. If you like this video, please do subscribe and feel free to comment.